Bismillahirrahmanirrahim. How are you, students? Today we will study unit number 2, kinematics, subject physics. Today's topic is distance time graph, but it is not limited to distance and time. Today we will study the graphical relation between distance, time, displacement, and time. Speed, distance, and time relation, displacement, time, and velocity relation, and the acceleration of change in velocity and time means acceleration. So we study relation between speed. Basically, the main topic is the graphical representation of speed, velocity, and acceleration. These are the main area on which we have to focus on. So if you look to the diagram, distance time graph is shown in the figure. Here it is the distance. Along y-axis, this is the distance. And along time axis, along x-axis, time is considered to be in second. So this line is parallel to x-axis, to time axis. So distance time graph showing an object at rest is, in this case, no distance is covered in this direction. So it means the body will be in state of rest. The body will be in state of rest because time is passing. Time is passing, and no distance is covered with respect to time. So it represents speed of a body which is 0. So it represents body at rest. Now, the next graph is between displacement, means position, final position and initial position. Position means displacement, and the time axis. So it's a straight line, which means equal distance in equal interval of time. Equal distance in equal interval of time. So velocity is constant and positive because the line is a straight line. Here it is a straight line. This is between position and time. The graph is moving in the downward direction. So the graph is in moving. Initially the velocity is more. Finally the velocity decreases. Velocity decreases. So the body is moving in this direction. So it represents negative velocity or decrease in velocity, or velocity is constant and negative. Velocity is constant means equal decrease in equal interval of time. Equal decrease in equal interval of time. So it represents negative acceleration also. Now, this graph shows speed, constant speed, but initial speed is not equal to 0. It takes from some certain value of speed, means the point from which the instant from which you start observation, the body has some speed, the body has cover some distance. This is again, distance is 0, no vertical movement, so distance is 0, distance is equal to 0, and the time is passing. So the body have 0 speed. The bodies will be in state of rest. As it is between distance and time, so speed should be considered because the distance time graph give you speed, not velocity. This is an accelerating body. The speed of the body is increasing, or variable speed. This graph show constant speed because the graph is a straight line. Displacement time, it will give you zero velocity because the graph is between displacement, so it will give you velocity. When it is between displacement and time, it will give you velocity. When it is between the distance and time, it will give you speed. Uniform speed velocity, variable velocity, distance time. Again, distance time graph for uniform speed. You can see this is for uniform speed, actually repetition of graph. Distance time graph for non-uniform speed, variable speed, because between distance and time, so it will give you speed. Now, it is now a complicated graph. So what is the speed showing on the graph in the time 5 seconds? So 5 seconds is this duration of time. This is 5 seconds. And this line represents 5, 10, 15, and this represents 20, and this represents 25. So at this point, distance is 25. 25 meter. Divide by time. It will give you speed. So speed is 5 meter per second. 5 meter per second. The speed is 5 meter per second. Speed is 5 meter per second. And during the time, which is 5 seconds, what is the distance time graph travel? Okay, at this interval, the speed is uniform, and during this interval, the speed, the body become stationary. The body will be in state of rest. So this graph is for stationary object. The object is at rest, and this is moving with uniform speed. So what is the distance traveled in the journey shown below? So you have to calculate the distance traveled during this journey. So in this case, you take velocity is given and time is given. Velocity and time is given. So you should calculate distance from this journey. First, you have initial velocity, which is 0. Initial velocity, you will take 0. You should consider final velocity. So you have two values, final velocity and initial velocity. And this is the total time for this journey. So from first equation of motion, which you didn't study still, you will calculate acceleration, and from second equation of motion, you will calculate the distance traveled. But you will study it in the next coming topics. So leave it. But just consider until and unless you didn't study first equation, second equation, and third equation, you cannot do this without these equations. You cannot do this graph without these equations. So it will be in the next coming topics, we will do it. What is the average speed of the journey shown below? So in this case, you take total velocity, average speed of the journey. You take the initial speed, which is 5, and the final, which is 25. So 5 plus 25 is equal to 30, so it's 15 meter per second. In this graph, it is 15 meter per second. You take initial and you take the final 25 divided by 2, you will get the average speed. Total distance divided by total time taken. So you take the initial velocity and average. One procedure is they take their average value, initial and sum up initial and final, and then divided by 2. And the second option is total distance traveled divided by total time taken, or total displacement divided by total time taken. So in this case, we have no displacement, we have velocity. So you will take the initial value of velocity and final value of velocity and divide by 2. It will give you the average speed. Or you take more values and then taking the average. Okay, in this journey, we have to find the value of time. This graph you will study, we will leave this graph until we cannot do this graph because until and unless you didn't study first equation, second equation, and third equation of motion, you cannot solve this one. So it will be before time. So inshallah, when we do first, second, and third equation of motion, we will solve this one. Now come to the table. Graph is shown in the figure. I will take 2 or 3 examples from this, and then you people will do it. Distance is 0, time is 0. So this is distance and this is the time. Distance 0, time 0. In 2 seconds, the body move 10 meter. So for 2 seconds, the distance is 10 meter. This is the table. And last, for 10 seconds, the distance is moved is 50 meter. So distance moved, time. This is the ratio of distance and time. If 10 is reduced to 5, 2 will be reduced to 1. So 1:5 ratio or 2:10 ratio means same thing. And the last one is 50, the ratio of 50 meter to 10 second is the same as 25 meter to 5 second. 1:5. So it's uniform speed. This graph represents uniform speed. Now you can see going away along vertical axis, distance is considered, and along x-axis, time is considered. This graph represents, which is written going away, uniform speed. This represents that the body is stationary and coming back with changing speed. So this is the variation in distance and time. So it's variable speed. So this graph is for variable speed, this is for stationary, and this one is for uniform speed. Now this again give you this graph is between displacement and time. So it represents uniform speed. Uniform speed. This graph is for other purposes, but we will just take concept of according to our needs and according to our syllabus. Now again, this graph shows, the red one shows an increasing acceleration, that is in a rocket using up its fuel. This graph is bends towards speed, so it's accelerating. And this graph the bluish lines bends towards the time axis, so it's decreasing acceleration. So bluish lines, when the graph is curved towards time axis, it represents deceleration, decrease in acceleration. When it bends to to speed excess, it represents increasing acceleration or positive acceleration. Displacement time graph. This graph one of the person leaves her house, walk up the road to her friend, whatever the name is, then down the road to her other friend. The graph shows her journey. Now calculate each of the following. Her total distance traveled, her final displacement, her velocity per each stage, her average speed, her average velocity. So distance is almost, the graph is between time and displacement. So in first case, the displacement is 30 meter. As it is the actual path also, so it should be considered distance also. Then 30 meter downward and 20 meter more. This distance is 30 meter. Then this is 30 and this is 20. So 30 plus 30 plus 20, total will become what? 80 meter. Our final displacement, as displacement is a vector quantity, so it is in the opposite direction, so minus 20. A body moves in this direction, plus 30. This in the opposite direction, minus 30 and minus 20, so 20 meter. Her velocity per each stage is 1.5 meter per second minus 2 meter per second. For total displacement divided by time, time is 20 and displacement is 30. So divide 20 by 30, you will get 1.5. As in the opposite direction, displacement is negative and it is 50. And time per that is almost 20, 10, 20, 25, 25 for this journey. The time is 25 seconds and displacement is minus 50. So it will become minus 2 meter per second. Her average speed, total displacement divided by total time. Her average velocity, displacement divided by time. Linear acceleration. This represents gradual acceleration. This represents no change in acceleration, zero acceleration. And this represents the deceleration of a body. And here, drop to zero, the acceleration drop to zero. This graph also shows distance time graph will give you speed. Here the speed is uniform. Here the body is in state of rest. Here the speed is again uniform. So it's different stages. Uniform, variable, zero, like different values. This is the distance time graph moving this one is displacement time graph represents different values. We discuss it separately. That this represents uniform speed. This represents zero speed. The body is in the stationary object, and this represents that the body, the decrease in the speed of a body, and same with velocity also. You can see the diagram. Time and distance, 20 meter, 20 meter, 20 meter, 20 meter, distance remains constant. Time is passing. So it represents the body which is in state of rest, state of rest, because no distance is traveled during this journey. This represents displacement time graph and represents velocity. If someone say that it is the free falling, this graph, this portion of graph is for free falling object, it will not be wrong. And this one is also for free falling object, then it is also precise. This one a little bit confusion, carry confusion. But this graph, this line is for free falling objects. If someone say that, because the body is thrown vertically with 20 meter per second, and it hit the ground with minus 20 meter per second. This graph is for the motion of an object, which reverses the direction. And this is also for the motion of an object which reverses its direction. Its value is minus 30 downward, and it's 40 upward. So it is the resultant values. As a whole, the object when the graph is between displacement and time, it will give you velocity. So sum of its portion represents free falling object. It's only a prediction on the basis of graph, on the basis of information that we get from the graph. And the mid graph does not show that the body is free falling objects. It's a uniform velocity which give you acceleration. Sometimes accelerating, sometimes the displacement is covered more, and they have the observation time is also more. So it represents different values of displacement and different values recorded in different interval of time taken, but equal interval of time taken. So this graph shows the motion of the velocity of an object, but you should explain it separately. A body initial velocity is 20, it comes to rest, then reverses its direction and increases its velocity to 20 meter per second. Here again the direction reverses, and here the value becomes 0, and in the opposite direction it will continue and reaches to 40 meter in a duration of 15 seconds. And here again reverses the direction, and you should explain it like this. Graph of motion, we already explained this graph. This graph, you'll do it as a home assignment. Take the explanation is written here, A, B, here it is written G, here F, E, D, A, B, C, D, E, F, G, H. Different points is given. You should, the acceleration, which type of acceleration at that point is, it is written in front of those points. In front of A, increasing acceleration, B, increasing acceleration, C, constant acceleration, D, decreasing acceleration, D and E, constant velocity, and constant velocity means zero acceleration. Again, E and F represents increasing deceleration, the deceleration. FG represents constant deceleration, and GH represents increasing deceleration. Distance time graph will give you speed. First, the greenish line represents uniform speed. The bluish line represents different speed, uniform speed, zero speed, and uniform speed but decreasing value. The red line represents variable speed. This is also a distance displacement time graph which give you different values of velocity. Here it is displacement time graph which is drawn for simple harmonic motion. It represents the variation in velocity, wave velocity. This graph also shows object accelerate in the first column, this one, in this column. In this column, object reaches constant velocity, object deaccelerate, and here object accelerates, object reaches constant velocity, and object deaccelerate. So different values. Stationary graph for stationary object is parallel to time axis, so it will be graph for stationary object. The first one is for rest, the second one is for uniform motion and uniform acceleration, the third one. Different values of velocity. What did Joe do at minute 10? At 10 minute, his velocity is, he reverses his direction. The direction of motion reverses at this point. He is changing his direction. At what speed was Joey moving for the last 30 minutes of the journey? This is the last 30 minutes. 30, 40, 50, 60, this graph. This graph represents uniform velocity, uniform speed. Body is moving with uniform speed. This is a different graph, but it will give you, it's blurred, so give it. You can see the diagram. The diagram shows the displacement time graph for a particle moving in a straight line. The average velocity for the interval t is equal to 0 and t is equal to 5 seconds is average velocity. So t is equal to 0 second, velocity is 0, and t is equal to 5 seconds, velocity is minus 10. So 0 plus minus 10 will be equal to the average velocity, the total, you will add the time recorded in time interval 0 and time interval 5 and divide by total by the average time. So when minus 10 is divided by 5, you will get minus 2 meters per second. So B option is the right option. Uniform speed, and this line represents stationary object. Stationary object because no change in displacement or distance. And here it represents steady speed. Carefully describe the motion in each section of this distance time graph. You will do it as a home assignment. Carefully describe the motion in each section of this distance time graph. A, B, C, and D section. At point A, B, and C, and D, you will describe displacement. As you can see, the body is moving. The values are recorded is shown in the diagram. This is displacement time graph. From this graph represents uniform velocity. This also represents uniform velocity, but the direction reverses. During this interval, the body is stationary, and in this direction, uniform speed, but with different ratio, but the direction reverses. Distance time graph, you can faster object traveling at constant speed because this is bends towards displacement distance axis. So it will be more acceleration as compared to this one. This graph is for stationary objects. Slower objects traveling at constant speed is the red line, which start from O. Faster object traveling at constant speed. Different speed. Bluish line represents acceleration and constant speed. Steady speed is the red line, greenish line is the deceleration, and again bluish line is increasing acceleration. This is velocity time graph, so it will give you acceleration. Acceleration versus time. Acceleration recorded in different interval of time is shown in the figure. So first is 0, 0, then it is 1.00, then 2.00, 3.00, 4.00. So equal change in velocity, equal increase in velocity. So increasing velocity and equally increasing velocity. And it's accelerating body. This graph represents accelerating body. Different different portion of the graph represents different values of acceleration. You can see velocity, distance time graph. This is for simple harmonic motion, and it will give you different variation in velocity or variation in speed. So today we studied distance time graph, displacement time graph, the graph for acceleration, for speed and variable velocity. So I hope so you will understand it, but we done more as compared to your syllabus. So if you have a confusion, don't get confused. In your book, there is simple graph. The graph are constant velocity, constant speed, zero stationary object, and acceleration. So graph will be simple for you. If you study this in, you try to learn all these graphs, you will understand the graphs of your book easily. So thank you, students. Wish you best of luck. Next topic is equation of motion.